So in the previous video, we saw how a single server setup would look like and why it won't be enough when it comes to single point of failure or scalability. In this video, let's look at how we can resolve that by adding load balancer and multiple servers and see how that goes on. I hope you're ready. Let's get started. Welcome back, engineers. In this video, let's cover what is a load balancer, how it works, and we'll see some common algorithms, and let's see a small demo about how a load balancer works, and let's see what happens when the load balancer itself goes down, right? Let's do it. So in the previous video, we saw that a single server setup would look like this. So there's basically a single web server and all the traffic is pointed to it, and this alone is responsible for handling all the performance and scalability and availability and so on. Right? But that's not very scalable or efficient, so we will add a load balancer. So how will that look like? So instead of using one server, I now want to add multiple servers. So I can add web server 1, web server 2, web server 3 as long as my needs are fulfilled. And we would need somebody in the middle to route traffic between these servers, right? So that's when we add a load balancer. So what is this load balancer? It is again a simple server which is taking care of taking in the incoming request and forwarding to one of these servers, right? And it is not only taking care of forwarding the request, it is also having some additional responsibilities like checking the health of each server. If one of the server goes down, automatically it will stop forwarding the request to it and forward the request to the other server. It will also take care of checking the health of these servers, like if they are over-occupied or not able to handle the request as it's expected to. So in that case also it will stop forwarding some request to it and spread the distribution among the multiple servers, right? And that is how a load balancer works. It takes incoming requests and forwards it to the respective servers. Another thing that we can achieve with load balancer is heightened security. Like if you see here, the load balancer is exposed to the public. Like load balancer can be called using some public IP and any browser or computer can access it, right? And the internal servers, the web servers themselves, need not be exposed to the outside world now because nobody is going to call them directly. Everybody will go through the load balancer, and load balancer can take care of forwarding the request with private IPs. So this network structure is a little more secure than what we saw before, and that is also another benefit that we get by using a load balancer, right? So how does a load balancer do all this? So for this, there are some common algorithms like defined here. So the first one is the round robin algorithm. So this is a straightforward algorithm. Let's say we have a load balancer here and it is taking care of forwarding requests to server 1, server 2 and server 3. And the round robin algorithm is quite simple. The first request would go to server 1, second request would go to server 2, third request would go to server 3, and all the servers are done. It comes back to server 1 and the fourth request would go here, fifth request would go here, and so on, right? It is a simple cycle algorithm, right? So that's how round robin works. So the second type of algorithm is the least connections algorithm. So this is how it goes. So instead of just keeping track of the health of the servers, it also keeps track of active connections. So all servers have 0 active connections to begin with, and when a request comes to the server, the number of connections is incremented, right? And when there is a concurrent request again, the load balancer will check who is having the least number of connections. And in this case, server 2 is found. So the second request will go to server 2 and the count is incremented, right? And so on. Third request will go to server 3 in case of concurrent requests, right? And what happens is, after the request is fulfilled, these servers can acknowledge back to the load balancer that, hey, I'm done now, you can reduce the count. So the count is going back to 0. So the server 1 is now available so that the next request can go to server 1 and this whole process repeats again, right? So for every request, we check who is having the least number of connections and we forward the request to that server, right? And the third one is IP hashing. So what happens with the IP hashing is, let's say there is client 1, client 2, client 3, and every client will have some IP address, right? And this IP address goes through a hash function which will give out some kind of a server identifier, 0 or 1 or 2. Let's say these servers are 0, 1, 2, right? So let's say for the first client, IP address goes into the hash function and we get the output as 1. So the request would go to server 2, right? And the next time any request comes from client 1, the same hash function would be invoked and we get the same output. So every time the request will go to server 2 from client 1. And similarly, the other clients will go through the hash function and they get their own respective servers. So this is particularly useful when we want to keep a sticky session and the server is tracking the session from the client, right? So if the server is not stateless and it needs to keep track of session, that's when we use IP hashing, right? So these are some of the common algorithms. So now I would like to show you a demo to show you how a load balancer works, and just to make you feel comfortable that we are not doing anything fancy here. So it is just a simple script that is taking care of servers and request forwarding, and we are not doing anything fancy. So let's see. So in this VS Code, I have two servers. So they are simple HTTP servers, and one is listening on port number 3001 and the second server is listening on port number 3002. So let's start them. So this will be my two servers. So server 1 is up, server 2 is up. So just to make sure they're running, we'll go to our browser and check localhost 3001. So response from server 1, and then we'll do the same thing here, 3002. Okay, so response from server 2. So both servers are up and running, but now we will add a load balancer. So let me start the load balancer and show you how it works. So the load balancer is using a mechanism of least connections right now. So what I'll do is I will open 10 tabs like this, and in all of them I'm going to hit localhost 3000. Localhost 3000 is where my load balancer is running. 3, 4, 5. Let's do 5 tabs, right? Now what I want to show you is I'm going to hit all the 5 tabs at the same time. So we're going to reload them, and all 5 tabs are hitting the server, the load balancer at the same time. And the load balancer is taking care of fulfilling the request. So let's see how it worked. The first tab, the first client got response from server 2, second one from server 1, third one from server 2, fourth one from server 2, fifth one from server 1. So how did it handle all this? So let's look at the code now. So what we are doing here, we are keeping a list of servers. Localhost 3001, 3002. If there are more servers, we can add to this list, and we are keeping track of active connections, 0, 0 to begin with. And then when there is a new request, we are asking for a server with the least connections. So how do we do that? We simply go through the list of all the servers and we keep track of a minimum, and we get the server that is having the minimum active connections. Okay, and we forward the request to that particular server. So this is just a script to forward the request, and after that, when we receive a finish event that the server has finished processing the event, we simply reduce the number of active connections, right? So that's how this whole algorithm goes. So very simple. Obviously, I've not added any edge cases or anything. This is just to show a demonstration of how a simple load balancer would work, right? So far in this video, we've seen what is a load balancer and how it is helpful. We've seen some common algorithms, and we've also seen a demo of a simple load balancer. Now you might be wondering, what if the load balancer goes down? So one of the main reasons why we added a load balancer is to make sure that there is no single point of failure, right? So this was one web server, and if this goes down, everything goes down. And by adding a load balancer, we did achieve some kind of distribution of load. So we have handled the scalability part But what about the single point of failure? So if this is the only server that is being exposed to the outside world, what happens if this fellow goes down and nobody can access them because these are private IPs, right? So let's take a closer look at this load balancer setup. So in reality, we would have more than one copy of load balancer running, at least two. And we use the concept of virtual router redundancy protocol to make sure that both of these servers, basically both of these load balancer servers, will have the same public IP address, right? And they are just using an active passive state, which means that only one of them will be active. And anybody who is hitting this IP address will either go through this or this, whichever is active. So how does this work? So they use something called VRRP, a virtual router redundancy protocol, which means one of the server is always redundant, right? It is not doing anything. And they are just checking with each other. Are you alive? Are you alive? Or do I need to take over? Are you alive? So if one of them goes down, let's say the active one goes down, the next heartbeat check from the passive server will make itself active and keeps checking for active server again. And when the active server comes back, depending on the priority, one of them can become active and one of them will remain passive. And the rest of the flow is simply the same, right? So this is the concept of VRRP. It's a very interesting topic. I'll leave some documentation for you to read through in the description. So definitely check it out if you're interested. Now I do have one question for you to think through and let me know in the comment below. If this VRRP was possible and two machines could have the same IP address, why couldn't we do that here? Why can't we just add more servers and one of them would be active, others would be passive, and the one active server, when it goes down, the other one could take its place. That way also we could avoid single point of failure, right? So why couldn't we do that? Why do we need this middle layer in the middle, right? Think about it and let me know in the comment. So whoever gives the right answer, I'll give you a heart, right? Fantastic. So that's all for this video, guys. We have seen what is a load balancer and how it works. And if you have any questions, definitely let me know. I will quickly see you in the next one. Thank you so much for watching. Do subscribe if you haven't done already. Do leave a like if you found this helpful. Thank you so much. Cheers.